CVPR 2025 paper discussion, Unified Video Action Model. This is a paper out of Stanford, links in the show notes. And I think this is probably one of the more interesting attempts that I've seen at CVPR so far to solve a really interesting problem, which is inverse dynamics. What is inverse dynamics? To paraphrase the paper, in robotics, we are interested in learning generalizable policies that map observations to actions. So we see something and then we act. That's what robotics do. And inverse dynamics is to infer actions from what we see. So this is one of the takeaways from this paper. What they're trying to do is unify video and action data, put it in one latent space. The reason they want to do this is because they want to combine the information of spatial orientation, which is what you see, with action. So, for example, if you, I used to be a ski racer, and we used to memorize the racetrack. So we used to think, or sometimes I think it's called dream surfing. Surfers do that with waves, right? You look at the wave and you imagine yourself how you're surfing that wave. Or in the ski racing example, I would imagine how I'm racing through the gates. And then eventually, once I do this enough, I can race without seeing the actual race track, or surf without seeing the wave. So that's kind of the analogy. What's interesting here is this unified representation first. So we look at different types of information, and then we kind of assume that there is a commonality here, that there is something we can express in one latent. I mean, that's how the paper explains it. And then from there, there's a couple of things that they're attempting to do. One is they want to be able to generate video data and action data at the same time. So this is one thing that, of course, is a big theme at CVPR 25, which is scene generation, or let's call it video generation or scene generation for robot learning. I think we've discussed this already several times. As a second order effect of Gen AI, we see robotics as the big winner here, because we can finally solve the data problem in robotics with Gen AI. We can generate virtual worlds in which robots can use techniques such as reinforcement learning at scale to learn policies. But what they need to do, of course, is to be able to combine spatial information with action data. That's what robots do. And I think the inverse dynamics are what Tesla's trying to do with Optimus, which is, for example, learn from internet scale YouTube videos, how in general, how to navigate throughout the real world. And I think that this is really interesting because, and I believe, Musk didn't say this in the CNBC interview, but I believe, or I think he believes, that the bitter lesson works pretty well when you have scale data. And since you don't have scale data in robotics, you must find a way to get that data. And a lot of researchers are trying to combine observations with actuators. And one way to do this is to do inverse dynamics, which is predict the actuators from what you see. And this is roughly what this paper is attempting to do with the unified, with unifying video and action data. So again, just to be clear, what is inverse dynamics? Given two frames of video, before and after, infer the action that caused the change. And once you can do that, you can then tie the action to a almost like a lookup table to a set of actuators, and combine the action with the actuator. So what you're really trying to do in the end is to move from what I see to what I need to do in order to act within the context of what I see. That's the holy grail. And I think this unified video action model is an attempt to solve the learning at scale from YouTube video. So to summarize this paper, in my opinion, it's an important step towards this solution. It's something Tesla's working on, so it's really important for us here at Orange Capital Partners. We have a large investment in Tesla. Our main theme is robotics or embodied AI. So we're not just investing in AI, but in embodied AI. And in order to learn in order to train embodied AI, we have to find a way to use simulation and or video data, and for that we need inverse dynamics. And this paper is one step towards that solution. Thank you.